There we go. Okay. All right, so 5.3. Today we're going to be doing, it's called graphs of radical functions, but essentially we're doing transformational work again. So all of those rules that we talked about, how you take a function and move it left, right, up, down, stretch and shrink and reflect and all that kind of stuff. Basically, it's going to be a review of those rules, but we're going to apply them to graphs of radical functions, so like square roots and cube roots and fourth roots and all of that kind of stuff. So there are a couple of parent functions or like starting functions that we need to make sure we understand what they look like, and then we can do all these different transformations to those things, okay? So first one, square root. And later in the hour, we're going to talk about why this thing is shaped the way that it is a little bit more. But it looks just like that. It just starts here at 0, 0, and kind of levels off a little bit as it goes up like that. So this is f of x equals the square root of x. So some points that are on the curve. 0, 0 should make sense. You plug in a 0, you get a 0, right? Square root of 0 is 0. If you plug in a 1, what should you get? So, well, just answer me. What do you get when you plug a 1 into that equation? What's the square root of 1? 1. So the point 1, 1 should also be on here. All right. If you plug in a 4, what do you get? 2. So the point 4, 2 is also going to be on there. Okay, etc. So like the point 9, 3 would be on there. 16, 4 would be on there. 25, 5 would be on there. You get it? Right? Doing the square roots of all of those x's to get the y's. Okay, so, and it ends up, and that's why it kind of ends up leveling off a little bit, because your x's get really big, but your y's don't increase by very much, okay? I have to make my x's get really large for my y's to go up by just a little bit each time. So it keeps getting shallower and shallower and shallower as it goes out. So, all right, so that's the basic shape of square root of x. Also, one we're going to be looking at quite a bit is the cube root of x. And it does kind of this look. Oh, no. Put a little gap there. Oh, that's all good. All right, so this one, notice how there's a tail end on this one and there wasn't on the other one. Okay? Can anybody explain why that is? Why do I have a piece of graph down here on this one that I didn't have on that one? Well, it's because this one is a cube root, but what is it about a cube root that lets this graph have an extra little piece down there? That's exactly right. It's odd. Okay? Can you take the square root, and again, we're just talking about real numbers here. Okay? We're not talking imaginary numbers. Can you take the square root of a negative number? No. Not when you're talking reals. Okay? So, can you take a cube root of a negative number? Yes. You can. Like, what's the cube root of negative 8?
Oh, right, because it's odd.
Right, because it's odd. So negative 2, right, is the cube root of negative 8, or the cube root of negative 27 is negative 3. So that's why this one has this little piece over here, because negative numbers are okay. I can use negative numbers, so I have all this negative stuff over here that works. On this one, it's got to stop at 0, 0. As soon as you let x get negative, suddenly it doesn't work anymore, because I can't take the square root of a negative number. Okay? So, talking about that, we can talk a little bit about domain. And we briefly talked about domain earlier in the year, and we haven't really touched on it again. But just to review with you guys here for a minute, a domain it's the set of all numbers that you can plug into a function. So, all numbers you can plug in, or all numbers that work, however you want to say it. And no, that's not a hashtag. So domain would be the set of all numbers that work in a function. So what's the domain then for a square root? What are all the numbers? 0 to infinity. Yeah, exactly. Or another way of saying that then would be the domain is x is greater than or equal to 0. Right? Starting at 0 up to infinity, so everything that's greater than or equal to 0 would be the domain for that one. Okay? What's the domain of a cube root? What numbers am I allowed to plug into a cube root? It's everything, right? Yeah, negative infinity to infinity. So one way that you can say that then is just all reals or all real numbers. Yeah, however you want to say that. And again, we say all real numbers because, right, again, we're not talking about imaginary numbers here. So just all real numbers work for the domain for that. So we're going to do some transformation stuff with these. And the domain, depending on what we're doing the transformation to, might change a little bit. Okay? And we're going to do some graphing. And we're going to look at the graphs and see if we can look at the graph and determine what the domain is based on how that looks and that sort of thing too. But these two are kind of like our home base. Okay? This is where we're starting from with all of these. And so it's a matter of if we know what the transformation is from these, we can then kind of track how the domain might change, if it changes when we do some work. So let's try that once, all right? So let's say we want to investigate f of x equals the cube root of 2x plus 3. All right, so we got to think back to all our little transformation rules. And in case you need a little refresher on that, if you go into the section in your textbook, 5.3, they have them all listed out again for you. So you can go back and look at those if you need to. So, can anybody tell me at least one thing? What's one transformation that you see in this equation here? Raise your hand and I will call on you and you can tell me. Ford? Nope. Yep. Nope. Can you give me the other one, though? Okay. So we can all agree at least you see an up 3 on there, right? I think what had you forward was it's not under the root symbol. It's on the outside. So that means it's an up or down movement. So, yeah, we definitely have an up 3 happening. Lucas said there was a vertical stretch of 2, and I said, that's not true. So what actually is happening with that little 2 on the inside there? Well, it's in the cube root, but what kind of a transformation is that allowing to have happen then? It's a horizontal shrink. Yes. Remember, when you multiply x by a number, not the entire equation, but just the x, that's a horizontal stretch or shrink. Right? You guys remember that rule? If not, we should probably go back and review that. Okay. Right. The 2 is not on the outside of the cube root. It's on the inside of the cube root. So I'm not multiplying the entire thing by 2. I'm multiplying just the x by 2, which means it's horizontal. And if it's horizontal, everything's backwards. So this is a horizontal shrink by a factor of 2. Or I guess you could say horizontal shrink 1/2. That would be more accurate. Okay, so the stretches and shrinks, we talked about this before. If you're just sketching a graph, those are kind of hard to see. But this should appear to be like a cube root, except it is kind of smashed in horizontally just a little bit more, and then it's going to move up 3. So it would look probably something like this. Okay, I tried to make that look more smashed, okay, compared to the other cube root up at the top there. All right, it's a little bit more squeezed in. And where is this point right here? That's 3. Because it moved up 3, right? So that little point where it crosses the origin should now be up at 3. So we got a horizontal shrink and we went up 3. So it would look something kind of like that. Okay, what's the domain of this thing? Look at the graph of that. Can you tell me what the domain would be? Mm-hmm. It's still all real numbers. There's no gaps anywhere or anything. And actually, what you're going to find is cube roots, no matter how we transform them, domain's always the same. It's always all real numbers. You can always stick whatever you want into them. Square roots get a little dicey, but the cube roots are always the same. So, since we're talking square root, let's look at one.
Cube root is always going to be all real numbers.
Mm-hmm.
Okay.
Yep, all real numbers, cube root, every time. You're safe. Now, because the square root starts with a domain that is just x greater than or equal to 0, if we do a transformation to that, then the domain could potentially switch to something else. So let's try this transformation real quick. Let's see if we can identify what's going on, sketch a graph, identify the domain. Okay, so there are two things happening on this one. So again, somebody raise their hand, tell me, what do you see? What's at least one transformation you recognize? Yep.
It's going
Left 4. Mm-hmm. Good. Remember, on the inside, it's always the opposite, right? You see a +4, it's actually moving to the left. Okay, and somebody else who has not spoken yet today, what else is happening on there? You already spoke. Somebody else new. Caleb, what do you see? What? You were pointing to him, so I'm going to call on you. What's that little negative in the front going to do? Nope, it's not a translation. It's a reflection. Right. Okay. So, do you know, is a reflection over the x-axis or a reflection over the y-axis? It's over the x-axis. Good. Yep. Okay. So, this means that I need to take my square root graph that we had up at the top. I need to move it to the left 4 and then reflect it down over the x-axis. Sketch what that would look like. Okay, so normally a square root looks like that. And so I'm going to move that to the left, 4. So at 4, so now it's doing something kind of like this. But we also want to reflect it over the x-axis. So it's going to look kind of like this. So I kind of covered up my 4, so that's a 4. Okay, and then I'll just get rid of these here. So looks like that. Okay, so look at that graph for a minute. What's its domain? Oh yeah, that's -4. So yeah, it should be -4 up to infinity. All of that's good, right? Can't go less than -4 though, because then there's nothing over there anymore. So how could I write that then as an inequality? What would it look like?
Greater than -4, I think. Or equal to.
There you go. Because it can be equal to -4. That's okay. Because that point is still part of the graph. So yeah, x greater than or equal to -4 would be that domain. Okay? So if you're able to draw a sketch of the thing, then you can get its domain pretty easily just by looking at, okay, what x values do I see it hitting as I'm going across there? All right, so these were examples of ones where I gave you the equations after the transformations had happened. We need to practice just a little bit again, starting the other way, where if I give you the parent function and I tell you what I want done, can you then build the equation so that it looks the right way? So we'll try a couple of those, and then we'll get into our calculator stuff here to finish up. All right, so I know we were just focusing on square root and cube root to begin with, but really any root we can do this stuff with. So let's say that our parent function is the 5th root of x. Okay, and I want you to apply the following in this order. I want you to move it to the right 3, and then make it go up 7, and then reflect over the y-axis. And again, it has to be in that order. So let's just take it one step at a time and change the equation, change the equation, change the equation, and see what we end up with when we're all the way done. Okay, so moving it to the right 3, how would that change the equation to get it started? Ford? You got it. Okay, so our first step, we have f of x equals the 5th root of x minus 3. Okay, somebody else. Move it up 7. What's that going to look like? To somebody other than Ford this time, because he's already answered once. Okay, good. Golden, plus 7. So f of x equals the 5th root of x minus 3. And then put a plus 7 on the outside. That moves it up 7. And then what do we do to reflect it over the y-axis? Somebody else, McKinnon? Negative on the x. Good. So 5th root of negative x minus 3 plus 7. Nice. Okay, got it. All right, we'll do one more. Let's have you guys, I want you to do this one, everybody on their own, start to finish. So we'll start with a 4th root of x and see if you can do these 3 things. So I want a vertical stretch 2, then take that and reflect it over the x-axis, and then move it to the left 4. Okay, take a couple minutes. Shouldn't take you too long. Try this one on your own. Start to finish. What do you got? All right, so check yours out. See if it matches mine. Should be negative 2, 4th root of x plus 4. We good? Question? Why wouldn't you put the 2 on the x? It's because it's vertical. Any kind of vertical stretch or shrink, you multiply on the outside. Horizontal's on the inside, yeah. So this one's different from that other one we were looking at earlier. It's not horizontal, it's vertical, yeah. Any other questions?
So then, if there was a horizontal stretch, you would have put like 1/2 in front of just x, right?
You got it, yep. Just on x, and you always do the reciprocal of it, yeah. So, okay, I think we're good with doing that sort of thing. So let's take a look at our calculator. I said we're going to graph some of these and try to identify what the domain is and that sort of thing. So let's take a look at... Now these equations are going to be in the same family, but they're not going to be like transformations quite like what you were doing there. And that's why we're using our calculator to do it. So let's do the square root of x squared minus 4. See what that thing looks like. Okay, so type it in your calculator. Give it a standard window too, so you have a decent look at it. And let's draw just a quick sketch of what we see, and then see if we can identify what the domain would be. I know it looks weird, right? It doesn't. Did you graph it yet? You looking at it? Yeah. So it doesn't really look like that parent function for a square root. It's like different. It almost looks like a couple of straight lines, but then it curves in a little bit at the end. Yes. Yeah, go for it. So it's kind of like that, right? This is at 2, and this is at -2. And then as these things go out, they start to kind of just turn into these straight lines that go on and on and on and on. So my question for you, though, is what's the domain of this thing? If you look at that graph, what values of x work with this thing, and which ones don't? Or maybe at least can you give me one piece of the domain? One group of numbers you know are definitely good. 2 and... Okay, so we got one group goes from 2 to infinity, and then -2 down to -infinity. Okay, so how would I describe that? Well, x is going to be, well, greater than or equal to 2 for sure, right? Okay, and x also is less than or equal to -2. So we could write it like that. Okay, so sometimes the domain comes in a couple of chunks, like that one. There's 2 pieces to the function. Yeah?
Is there like any way that you can put, like, how we use, Karen, when we did it, but like, when you did, like, we put -2, and then, like, the greater than or equal to
Oh,
x,
yeah. If you want to do it like that, let's see. So this one here would be 2 less than or equal to x less than or equal to infinity. And this one would be -infinity less than or equal to x less than or equal to -2. You could do them like that. Yep, if you prefer that, that's fine. Okay, so some that you're going to graph on the calculator and analyze are just like that. Other ones, you're going to have to create the equation or equations to take a look at it. So something like this. X equals 1/2 y squared. You can't put that in your calculator the way that it is. Because when you put equations in your calculator, you have to use the y equals menu. Is this a y equals equation? No. This is an x equals equation. So what do you suppose you need to do to this equation so that you can put it in your calculator? You need to turn it into a y equals equation. You need to solve this thing for y. Okay, well, we've done this sort of thing before. So somebody give me a first step. What should I do? Multiply by 2. Okay. So 2x equals y squared. Okay, and then what? Square root. Now remember, when I'm working with square roots in an equation to solve them, if I'm square rooting both sides, like I'm going to have to do on this one, what has to come along with the square root always? Plus or minus, right? You guys remember that? We were talking about that before when we were solving equations by square rooting. You have to do a plus or minus. So, y is equal to plus or minus the square root of 2x. Right? When I do this step here by square rooting both sides, I need to have this little thing here. Well, there is no plus or minus button that you can use on your calculator. So what that means is I'm actually going to have to graph this thing as 2 equations, not just one. Okay, and you can do more than one at the same time on your calculator. That's okay. So this is going to become y equals square root of 2x is one of the ones you're going to graph, and the other one you're going to graph is y equals negative square root of 2x. So do that. Go into your y equals, punch in both of those two things, and take a look. You should see something that looks a little familiar. It's a parabola, yeah. Now, here's the thing. A parabola on its side is not a function. Doesn't pass the vertical line test. Okay. However, each one of these by themselves is a function. One of them just gives you the top half. The other one gives you the bottom half of that thing. Okay. Even when you graph it, it does it one piece at a time. So you've got the top half and then the bottom half. Okay. And we actually studied these kind of parabolas before, right? If you guys remember back in, I think it was chapter 2, we were looking at quadratics, and we were graphing some of these things on their sides, all right? So square roots and parabolas have a relationship, right? Take a look at, what if I just graph the top half of this thing? I got rid of this one and just graph the top half. What does that look like? What does it look like the graph of? It's a square root. A parabola is really just two square roots put together. Or another way of looking at it is a square root is just a half parabola, really, on its side. It's a half parabola on its side. So to graph this equation, I do both of these two, and then I can take a look at it. Okay, let's do one more like that we have to break apart. We can also graph circles on our calculators. Okay, I don't know how much you guys remember from geometry with this stuff, but don't remember graphing circles. Some classes got to it, some of them didn't. So this may or may not be familiar to you. But equations of circles in general are x squared plus y squared equals r squared. And the r is the radius. So the radius of this circle is 5. So we're going to graph a circle with a radius of 5. Now, to put it in our calculator to do that, again, I can't type it in like this, right? I have to solve it for y and see what I have. Okay, so what's my first step in solving for y here? Don't minus 25. Minus the x squared. We're going to try and get y by itself. So y squared is 25 minus x squared. Okay. And then if I do this whole square root business, y is equal to plus or minus, again, square root of 25 minus x squared. And be careful, the square root of 25 minus x squared is not 5 minus x. Okay, you can't distribute a square root to each individual term like that. So this is what we have to work with. So this is what we're going to have to split apart into two. So we've got y equals the positive square root of 25 minus x squared. And then also y equals the negative square root of 25 minus x squared. So type those up real quick. Take a look. One of these equations is going to give you the top half of the circle, and the other equation is going to give you the bottom half of the circle. And your circle's probably going to look like an oval. And there's a reason for that, and I will explain that once everybody's there. But go ahead and type it in and graph it and look. Mm-hmm. Oh, yours is all weird. Hold on a second. I can fix that. Destiny, yours should work now. All right, so if you were to come up and look at my calculator right now, it would appear to be an oval, okay? I'm going to put it on here so you can see it, but this projector stretches things vertically. So mine looks like an oval, but when I put it on here, it's going to look like a circle because the projector is going to stretch the image, so it actually looks like a circle. So mine right now looks pretty circular.
You can still tell those.
It's a little bit of an oval. All right, so for yours, if you want it to look like an actual circle, the problem is your screen is a rectangle. It's not a square. Take a look. The actual screen on your calculator is wider than it is tall, right? So if you want it to actually have a picture on there that is like proportional, that actually like the divisions going this way and the divisions going this way are the same space, you have to do this thing called zoom square. So if you go to zoom, go down to number 5 where it says z square, and then redraw it, it should look more like a circle. Now mine looks stretched vertically because, again, the projector stretches it vertically. But in any event, now something else too, you guys see these little gaps that it puts in there? Okay, that's just the calculator having a glitch. Okay, it has trouble plotting those little points as it gets closer to the x-axis for whatever reason. But mathematically, it should actually connect. Okay, so it does make a circle there. Okay, so in your homework, you might be asked to graph some of these things, and so that this is how you can do it, so you can punch it in your calculator and actually look at the thing. Okay, so all right, that's all I got for you guys. So the rest of the time is yours to get going on some homework here. All right, there you go, guys.